There I was one evening, giving someone a lift home, when they suddenly said that they had decided EVs were not ethical because of the manufacturing of the batteries. So yeah, about that. I've struggled a little bit with how best to approach this topic, how to structure the video. One option was to create a video per element used in an EV, but I decided that would probably be too fragmented to be easily digestible. What I have decided to do instead is a single video broaching this subject. I'm going to do a fairly light touch on each of the elements used in an EV and the ethics associated with them. That keeps the video to a sensible length. So the first thing we should talk about are rare earth elements. The good news is that EV batteries contain no rare earth elements at all. Not a one. If you read an article talking about rare earth elements and EV batteries, then you should ignore it. They don't know what they're talking about, and you need to get your information from better sources than people who make that mistake. Rare earth elements are badly named in that they are not all that rare. These are a specific set of elements that do not exist anywhere in particularly high concentrations, and they were thought to be rare a long time ago, which is the origin of the name. Now, many EVs do use a bit of rare earth elements, just not in the battery. The main rare earth element to discuss is neodymium, which is used to make very strong magnets for all sorts of things, one of which is EVs. Many EVs use permanent magnet motors, as they offer a very efficient motor in a small package. So it is within the magnets of the main motor that we find the rare earths, about 200 grams of them. Mining rare earths is of concern because it can cause local pollution, as a result of the mismanagement of the waste byproducts, which contain other elements that can be toxic. Motors are everywhere in our modern world, including in internal combustion engine cars. Think of what powers the electric windows, electric seats, the wipers, the headlight adjusters and electric tailgates, to name just a few. And fun fact, the starter motor in most internal combustion engine cars also contain neodymium magnets, although they will be much smaller, as a starter motor needs to be much less powerful than an EV traction motor. As I mentioned, on average an EV motor will contain about 200 grams of rare earths. So whilst it's not nothing, it's perhaps not the largest of concerns we might want to cover today. We certainly need to be careful with the waste management associated with the extraction of rare earth elements, but this issue is thought to be manageable. However, putting pressure on car manufacturers will certainly do no harm. That should ensure they scrutinise mine owners and operators and ensure that they take responsibility for waste management. Okay, so next up is the critical minerals. This is what people should be calling the minerals used in rechargeable batteries, including those in EVs. The main elements needed to create a lithium-ion battery are lithium, nickel, manganese and cobalt, and graphite. Let's talk quickly about each of these, starting with lithium. Lithium is a very abundant element. It is widely available and can be extracted from several different types of resource. Most lithium comes from either brines or hard rocks, although clays containing lithium are also being investigated, especially in the United States. As we can see from this graph from Our World in Data, the largest exporter of lithium is Australia, with Chile being the next largest and China third. There has been concern about the lithium extraction methods used in South America, whose lithium resources are largely salt brines in underground watercourses. These brines are pumped to the surface and placed into large ponds, where they are allowed to evaporate in the sun, thereby concentrating the salts ready for collection. This approach can put pressure on the availability of groundwater in the area, and companies can be tempted to ignore the needs of indigenous peoples in their extraction processes. Clearly, we don't want people to be disadvantaged by the extraction of these natural resources, so we need to be very careful about the sustainability of this part of the supply chain, and that's an ongoing concern in that part of the world. Next up is cobalt. Most cobalt reserves seem to be highly concentrated in just a few areas, including, most notably and famously, the Democratic Republic of Congo. In 2016, Amnesty International released a paper highlighting human rights abuses in the DRC associated with artisanal mining, including the mining of cobalt, where they witnessed child labour in use at a number of mines they visited. Highlighting this problem to car makers resulted in a number of them taking action, and several initiatives have been launched to tackle the issue, most notably the Fair Cobalt Alliance and the Responsible Cobalt Initiative. This continues to be an area of concern, as the DRC currently supplies about 70% of the world's cobalt, and about 20% of that comes from artisanal and small mines known as ASM. So in total, about 14% of the world's supply is from ASM. We have to be careful how we tackle this problem, as these small mining operations provide income to a significant number of very poor people. The solution must not stop them from earning an income, but must instead reward safe practices and avoid child labour. So we have to trust that the charities on the ground will manage to steer them in the right direction. Car companies cannot have their reputations tarnished by being associated with unsafe or poor working practices, so they will move away from using cobalt from ASM sources if those sources cannot be encouraged to use safer mining practices. That would risk impacting the income of the people who are using cobalt mining as a way to earn a crust to pay their way. As it happens, cobalt is the most expensive element used in EV batteries, so we're seeing a dramatic reduction in the amount being used to make them cheaper. And some models of car are now available that use chemistries with no cobalt at all. Those chemistries are currently less energy dense than the traditional lithium-ion NMC battery, so the cars using them have lower ranges. However, I think we can expect to see the problem of energy density largely overcome, and the use of cobalt continue to decline in the coming years. Graphite has largely come from areas in which forced labour is a significant risk, especially in China. And there are also concerns about deforestation, habitat degradation and water contamination. Having said that, China started pivoting from natural to synthetic graphite in 2021 to avoid environmental concerns. And they also recently announced a cut in the export of graphite anyway, so Turkey and Brazil may start to become much more significant in this market in the coming years. Next up is manganese. A third of the world's current supply of manganese is from South Africa, a country that stands accused of human rights abuses associated with most of its mining practices. However, as we will see a bit later, the manganese used for EVs isn't all that much of a concern. Stay with me a minute, I'll come back to that. When it comes to nickel, about 40% is currently sourced from Indonesia. In February this year, a report was published accusing one large Indonesian nickel project of land right violations, deforestation and pollution. So, across all of these elements, it's clear that there are some major problems. All we seem to be finding is human rights abuses and environmental harm. So surely EVs are a terrible idea then? Well, it's complex, isn't it? All of our extraction of all the resources we use can result in exploitation. And other than lithium and cobalt, the elements we've talked about are used for a myriad of other things besides EVs. What is more, fossil fuel extraction isn't without its abuses either. We don't need to look far to find stories of human rights abuses associated with the extraction of oil, coal and gas. Do that Google and you will quickly wish that you hadn't. Unfortunately, there are news articles aplenty online about the pollution of land, water and air caused by the extraction of fossil fuels. Indeed, there are also a lot of allegations of some pretty terrible practices. Property rights violations, including forced relocation, bribery and corruption, forced labour, illegal detention and torture, and death. These are not things you want to be associated with, are they? All of these phrases were taken from a cursory search across news stories about the fossil fuel industry, and we have to hope that they are not all true, but I fear some of them might be, and that we users of fossil fuels need to take responsibility for our part in those abuses. So it feels like we've reached an impasse. Extraction is bad, and all types of car are affected. So what do we do? Well, let's try to look at the scale of the extraction and see if we can read anything into that. So we're going to list some numbers here. These are all taken from the British Geological Survey and detail the quantity of materials extracted worldwide in 2021, all in metric tonnes. Sadly, 2021 is the most recent data the British Geological Survey have exposed. Getting good quality data of this type is not easy. Whilst I would much prefer to have used more recent information, this is the most comprehensive and up-to-date survey I've been able to find. But first, I think we need some perspective, otherwise we have no way to judge these numbers. Let's use gold for comparison. Gold is a precious metal and one we consider to be quite rare. In 2021, the world extracted just over 3,000 tonnes of gold. That's a pretty big number, isn't it? Much bigger than I expected. But that gives us a yardstick to measure by as we move forward. 3,000 tonnes of gold. So let's start listing the various minerals we've been talking about for comparison. First, rare earths. These are all combined together. Of those, we extracted 15,000 tonnes. So rare earths are 5 times less rare than gold. Lithium extraction reached 115,000 tonnes. That sounds like a lot. For cobalt, we extracted 131,000 tonnes. Ouch. Next, 1.3 million tonnes of graphite and 2.8 million tonnes of nickel. So getting on for 1,000 times more nickel than gold. Yeah, that's got to be a lot, right? But actually we extracted 56 million tonnes of manganese. Manganese is already used for a lot of things besides EV batteries. So maybe gold isn't a great yardstick after all. Maybe we need a different one. Okay, let's try aluminium, or aluminum for our American viewers. We extracted 67 million tonnes of aluminium in 2021. Wow. The numbers are looking different now. So we can start to see that lithium and cobalt, the elements you might have been told to worry about, are actually starting to look pretty small beans in the grand scheme of things. But we're not finished, because that's a drop in the ocean compared to iron ore. In 2021, we extracted 3.1 billion tonnes of iron ore. Billion. That's American billion, in other words, 1,000 million. So the quantities of lithium and cobalt we are extracting are now looking pretty small. But we haven't quite finished yet. The largest extractions we make are fossil fuels. The largest of the lot is coal, at 7.8 billion tonnes in 2021. But we also extract 4.2 billion tonnes of crude oil. 4.2 billion tonnes of oil extracted every year. That's a pretty extraordinary figure, isn't it? It looks like about 70% of the oil that is extracted is refined into either petrol or diesel, and an awful lot of that is burned for transportation. And that's the interesting thing about the comparison, right? We extract most minerals to make something that we use for a long time. That includes what you now hopefully see as quite a small amount of material that is extracted to make lithium-ion batteries. And yet the vast majority of the oil we extract is used once by burning it, which generates eye-watering amounts of carbon dioxide as we do so, all of which we dump into the atmosphere, along with the particulate emissions and other combustion byproducts that the burning process generates. Once we have enough, we will be able to recycle the lithium-ion batteries used in EVs to reduce the additional extraction of minerals required for batteries in the future. However, we can't recycle the fossil fuels that are burned, including those powering ICE cars. Once we've used them, their byproducts escape into the atmosphere and we need to extract more, endlessly. So far, we've been talking about the minerals extracted in past years, and we know that to ramp the production of EVs, we're going to have to increase the extraction of the minerals needed to do so. The predictions are for demand in a few of these minerals, especially lithium, to grow about tenfold in the next decade. So that increases the need for lithium, and perhaps cobalt, into the million-ton range by 2035. Assuming, that is, that lithium-ion remains the dominant chemistry by then, which it might not. Sodium-ion is starting to be used instead now in some applications, because sodium-based chemistries will be easier and cheaper to scale. But even if we ignore sodium-ion, a couple of million tons of these elements is still several thousand times less than the oil we use each year. So the scale of the extraction remains in a different league in comparison to fossil fuels. And I think it seems reasonable to imagine that the scale of the human rights abuses could be correlated with the scale of extraction, and in particular with the money that can be earned from that extraction and use. We cannot, should not, ignore the scale of the problems fossil fuels cause. They are, unfortunately, many and varied. And this is something I might come back to discuss in more detail in a future video. But just as an example, a study released in 2019, based upon 2015 data, estimates that every year, globally, 3.6 million people die from the effects of air pollution generated by burning fossil fuels. How can we consider it to be ethical to ignore that loss of life? The fact that we've turned a blind eye to it in the past doesn't mean it's ethical to continue to do so. And I ask you this, how ethical is it to leave future generations with the adverse effects of our CO2 emissions, the emissions that we continue to make in ever-increasing quantities? The fossil fuel industry are not daft. They know that change is hard for us, and so they provoke us into debating the ethics of a new type of resource extraction, hoping that their misdirection allows them to continue their unethical behaviour unabated, while we delay making any change. In summary, the extraction of the minerals we need to build EVs is not ideal, far from it, but it requires so much less extraction than the use of fossil fuels that the ethics are surely on the side of EVs. Fossil fuel use, after all, generates ethical dilemmas of its own, and it's easy to overlook that. At this moment in time, we really have two options. We can continue to extract and use fossil fuels unsustainably. Extract, burn, extract more. Or we can move to a more sustainable future where we extract less, reuse and recycle. Neither option is perfect, but I think one is less imperfect than the other, and surely taking the path of least damage is the most ethical thing we can do next. We've all got a long way to go on our clean energy journey, and we need to be careful to avoid misinformation and misdirection being used to stop us progressing. Thanks very much for joining me. I hope you've enjoyed the video. Your questions and comments on this subject are most welcome in the section below. If you've liked the video, then it's a help to me if you click the thumbs up button, And it would also help me reach my stretch goal of 1,000 subscribers if you would also subscribe if you haven't done so already. Thanks.